So heat transfer for chapter 11, lesson 5. We're not going to read about the French fries, but how is temperature measured? All substances are made up of tiny particles, atoms, and molecules that are constantly moving. The faster the particles are moving, the more energy they have. Temperature is the average amount of energy of motion of each particle of a substance. In figure 1, the hot tea in the teapot is the same temperature as the hot tea in the teacup. But do they have the same thermal energy? We'll have to figure that out. We are on currently page 398, so you will have to turn to page 399. Thermal energy measures the total energy of motion in the particles of a substance. This means that the tea in the pot has more thermal energy than the tea in the cup because it has more mass. So it has more like in there. Measuring temperature. Temperature is an important factor affecting weather. Air temperature is usually measured with a thermometer. A thermometer is a device that measures temperature. Some thermometers have a tiny glass tube with a bulb on one end that holds liquid mercury or colored alcohol. When the air temperature increases, the temperature of the liquid in the bulb increases. This causes the liquid to expand and rise up the column. Temperature scales. Temperature is measured in units called degrees. Two temperature scales are the Celsius scale and the Fahrenheit scale. On the Celsius scale at sea level, the freezing point of water is 0 degrees Celsius, when the boiling point is 100 degrees. On the Fahrenheit scale at sea level, the freezing point of water 32 degrees Fahrenheit and the boiling point is 212 degrees. Whoa, Fahrenheit. To convert from Fahrenheit to Celsius, you would use the following formula. Fahrenheit minus 32 divided by 1.8 Celsius. We don't have to necessarily know all of that. We'll turn to page 400. We'll talk about convection, conduction, and radiation. We learned about that stuff before. So exciting. So this will kind of just be a little recap for us. Convection is fluids, liquids, and gases, atoms, and molecules can move easily from one place to another. As they move, their energy moves along with them. The transfer of heat by the movement of a fluid is called convection. That would be like in boiling water. Conduction is like your feet in the sand. The transfer of heat between two substances that are direct contact is called conduction. In figure 2, heat is being conducted between the pot and the grate and between the pot and the liquid. When a fast-moving molecule bumps into a slower-moving molecule, the faster molecule transfers some of its energy to the slower. So pretend you're in line and somebody is walking too slow in front of you. Just give them a little push, you give them some of your energy. The closer together the molecules are in the substance, the better they conduct heat. Conduction works well in some liquids, such as metals, but not as well in liquids or gases. Air and water do not conduct heat well. So we more or less need metals. Radiation. Have you ever warmed yourself by campfire or felt the heat of the sun's rays on your face? You can feel the transfer of energy by radiation. Radiation is the direct transfer of energy by electromagnetic waves. Most of the heat you feel from the sun travels to you as an infrared radiation. You cannot see infrared radiation, but you can feel it as heat. So we'll turn the page. So we learned about those transfers of energy before. We are now on page 401, which is this little bitty part here, and then the chapter is done. So heating the troposphere, that's where we live. Radiation, conduction, and convection work together to heat the troposphere. Notice in figure 3 how the sun's radiation heats Earth's surfaces during the day, and the land gets warmer than the air. Air doesn't conduct heat well, so only the first few meters of troposphere are heated by conduction. When ground level air warms up, its molecules move more rapidly. As they bump into each other, they move farther apart, making the air less dense. Cooler, denser air sinks towards the surface, forcing the warmer air to rise up. The upward movement of warm air and downward movement of cool air forms convection currents. So they kind of roll themselves, just like in this picture right here. Heat is transferred mostly by convection during the troposphere.